You were supposed to have all this done. I'm not going to walk around and check because as I said, we are very busy today because of the weather. So just check, tick, or X. Have a quick look. We can come back to it after we've gotten through everything I want to do today, okay? And there is the answer with pi. So the real answer looks to be 77,900 blah. I can check that very quickly for you because even though I go out of my way to say you should leave it like that, a great many of you refuse to leave it like that. So it is 2,500. I can't remember where pi is on this one. There it is. 7,853. This page again shouldn't have been too much trouble. This question causes a lot of trouble. In yours, is that little squared there? Is it there? It should be there, right? Yeah. So I've given you the area of the base right there. So all you had to do, area of base times height. But because it's a pyramid, you got to divide by 3. So it was 39. Square pyramid, 16 times 15 divided by 3, 80. This was all volume. Yes, volume of a sphere. There you go. Volume of a cone, area of base divided by 3 because it's a pyramid. There you go. And this was, we just did 2,500 pi. 7,853. Really 54, but that close. Everybody should be good with volume. Now we get to the tough pages. So, this thing right here, I'm going to erase all this poop. If this cylinder wasn't cut out, that's the surface area, yes? Everyone agrees, right? But I cut it out. So as soon as I cut it out, in surface area, what did I make right here? If I dipped that in paint, would paint go into that hole? So what did I create? New surface. So I had to add the sides of the cylinder, right? And the sides of the cylinder are 2 pi RH. But this is now a hole in it, isn't it? So I actually removed 2 circles. Everybody understand? Then you just do the math. Volume is different. Because in volume, I had the prism and I just removed the cylinder. Nothing new was added, only removal. Everybody understand? This is a big problem for kids. Most kids get one or the other, like, oh yeah, okay, I cut it in half. I made a new surface, so I got to add to it. But then you start doing weird stuff with volume. Right? Let me give you an example. This box has this volume of cards, yes? Now what does it have? The original volume of cards minus this, right? This box has this surface area of cards, right? This face, this face, this face, this face, this face in the bottom, yes? If I remove some of it, I just created a bunch of new faces, right? So new surfaces were added. That's why it is called surface area. We are only looking at the surfaces. Volume is what is there. Everybody cool? And this one always causes trouble. The black cone. Actually, I will change that color. The pink cone, which would be the whole cone, correct? Right? But I removed the yellow cone, which would have been right here, right? Right? But when I cut it off, I did a new surface, yes? So I removed the sides of the cone, pi r slant, but I kept this part of the cone, which is pi r squared. Cool? Everybody understand? I'm taking that as a yes. And volume, of course, big cone minus little cone, because there's no new volume. This is the cylinder that's been cut in half. So, obviously, that's a cylinder, yes? Right? But I cut it in half, so I divide by 2. Cancel, cancel, cancel. Pi r squared plus pi rh. But I made this new green rectangle, which is right there. Then you just add it up. Volume, of course, pi r squared divided by h. Or pi r squared h divided by 2, because no new volume. And hemisphere, we did these notes. Surface area, hemisphere, 3 pi r squared. Volume of a hemisphere, 2 pi r cubed over 3. Got it right there. And the last one, a grain silo. Not a great question if you don't know what a grain silo is, yes? Came off an old provincial exam. Doesn't really make sense. But a grain silo are those things on farms. They look like a missile. There's a door there. There's a door up there. And you put your stuff inside and fill it up. Now, even if you don't know what a grain silo looks like, I explain it. A cylinder with a hemisphere, or a hemisphere on top of a cylinder. So even if you don't know what one looks like, shouldn't have been a problem, right? The volume of the silo. How full can you fill it? Well, you would fill up a cylinder, and then you would fill up the hemisphere on top. Cylinder plus a hemisphere. Done. Everybody good? All right. This page. There is the right answer. A lot of people were very confused. I put that there on purpose. I drew this badly on purpose because you guys look at the drawing without looking at the information. This is what it really looks like. It's 15 there and 1. But then the other side is 8. So it's 7 here plus 1. Everybody understand? And then, of course, we are filling the pool up. So it is volume, right? This shape repeats, doesn't it? Back there, right? So that makes this the base. And that makes this the height. So 15 by 1 is 15. Then you did this one here. Got 67.5 times 6 to get the volume of the whole pool, which was 405. Then you multiply by 0.85 to get how many meters cubed. Then, of course, you divide it by 1.8 to get 191.25 hours. Or, of course, since hours are not measured in decimals, 191 hours, 15 minutes. The next question is very, seems difficult, but it's not too bad because, of course, it's just canceling because it's all metric, right? 1 liter of water is 1,000 centimeters cubed, right? I have 344.25 meters cubed. So I need to convert that to centimeters cubed. Now, we talked about this on a previous page. If I am converting cubes, how many times do I need to convert? 3 times, 1 for each dimension. So, if I'm going meters to centimeters, I'm multiplying by 100, aren't I? And then I'm multiplying by 100 again to cover the second dimension. Then I am multiplying by 100 again to cover the third dimension. And I get a gigantic number, which I will show you in a moment. 344.25 times 100 cubed 3 times. 344,250,000. Right? 1 liter is that many centimeters. So I divide that by 1,000, and I then cancel 3 digits. So the pool takes 344,250 liters. Next question. And my good friend Braden worked very hard on this question. But, and it's not just him, everybody makes the same mistake. Everybody thinks it's volume, right? Because you're filling the net, yes? So, it's not really, and I'm about to show you why. If I look at the net from the top down, okay? Pretend I'm looking down on the ice. So if I look down on the ice, there's the red line, right? And the net would look like this, yes? So if I'm filling that net, pucks look like this, don't they? What's this right here? Empty space. So if I put 6 pucks back there in a row, all of this is empty space, isn't it? So I can't use volume. This distance was 100 centimeters, yes? It's an average depth of 1 meter, right? And this distance was 1.83, yes? Everyone agrees? Okay. A puck has a diameter of 7.2, yeah? 7.62, yes? So I can put 1 puck there, and that is 7.62, right? So how many pucks can I put across this way? What do I have to do with those 2 numbers? What am I doing with the 1.83 meters? There's only 4 kinds of math, ladies and gentlemen. Even if you didn't get the question right, somebody should be telling me what I have done to this distance. You got a 1 in 4 shot, even if you don't know anything about numbers. What is it? What math are you doing when you take something and cut it into pieces? Thank you. You are dividing. But I'm not dividing 1.83 by 7, am I? Because what is this really? 183 divided by 7.62, which gets me I can put 24 pucks across here. I cannot put a 25th, can I? So I can have 24 pucks on the ground, yes? How far back can I go? 100 centimeters. I'm cutting it into puck distances. What is it? 100 divided by what? 7.62. And what do I get? So I can have 13 pucks going backwards, yes? So if I got 13 pucks this way, and I got 24 pucks this way, how many pucks are sitting on the ice? What math do I do? What's my width of puck? Multiply. So length and width gets me how many pucks on the ground? 312. Okay. Now, let's change. We're going up the net. So I still have 1.83. How tall is the net? 122, right? I know I've got 24 pucks across the bottom. Up, I divide by how much? How thick is the puck? So how many pucks can I go up? So I go up 48, and I know on the ground I've got 312, right? So what do? If there's 312 pucks down here, what do I multiply that by? 48, because I can stack them up 48 tall to get an answer of... Everybody understand? Is it a real life question? Obviously not. Does it require you to think? Very much so. In real life, you have to think about how to solve problems with stuff that you already know. Turn the page over. This required some estimation. Word. The green part is where the label is on a soup can, yes? So we don't need the 2 pi r's in a cylinder, do we? Because the label's only on the side. It's just 2 pi rh. So it was 102 pi, but they make 100,000 cans a day. So it was 10,200,000 pi centimeters squared. But centimeters squared is a stupid way to measure something big like the walls of our room, yes? So we convert it. Since it's centimeters squared, we need to convert by 100 twice. So it's 3,100 meters squared. Everybody understand? All right. How big are the walls of our room? Well, you were supposed to estimate it, right? We had a whole page about estimating, yeah? What did we say was about a meter? Way back on the first day we did measurement. What? A yard is about a meter? Oh, great. Okay, what's a yard? Okay, again. Remember this whole page where we talked about reference, because nobody brought out a tape measure. I gave you an hour to do this. Not one person brought out a tape measure. So what should you have done? You said a meter was about a step. I didn't see anybody walking the length of the class. But if you had done it, you would have walked that length and that length, yes? And then you would have gotten some numbers. Right? I believe this class is 11 big steps by 14 big steps. Now I want to cover the walls though, don't I? So you have to take that distance, which if we say is 11, and turn it sideways. Does it look about the same to get up to there? If you think it doesn't, you have to decide the fraction it is. Right? I think it's about the same to get up to the bottom of the triangle up there. Okay, so that means that's 11 by 11, yes? And how many of that size wall are there? There's that one and that one, yes? So I would have 11 by 11. Oh, here, we have the numbers. We went with 13 by 10 last year when we did this. Not 14 and 11. So 13 by 10. And then you just divide, right? So if we said that was 11 and 11, then you would do the same thing up in the triangle, and you would just add it up and divide it. What's the point of the question? Is it a real-life question? No, it's idiotic. But what does it make you do? Estimate distances, and it makes you let go of the fact that you've got to find a real-life answer. It's not important. That's not where the thinking is, right? And then we had the bike wheels. The front wheel circumference is pi times the diameter. So the circumference is 52 pi inches. 52 times pi is 163 inches. I want that in feet and inches, so I divide by 12, and I got 13 feet, 7 inches. Now in meters and centimeters, you take the inches, change it to centimeters, 414. Change that to meters, 4 meters, 14 centimeters. To travel 1 kilometer, 1,000 meters divided by the distance you could travel with one turn, 241 turns. Then the bottom one, same thing. You find the bottom. You find it to be 1.43 meters. Then you do that division. And that is all I asked you to do. Now, listen carefully. You will see in your books 2 pages of solving equations, I believe. Yes? Solving formula. That is algebra. You need to practice algebra. So what you're going to do for the rest of today, which is almost an hour, for the first little bit, you're going to work on, we're going to start these together to the point where you could do the algebra. All right? Probably do the first one together, then I'm going to shut up. Then, listen carefully. Your review starts on page 226. That review is to be done for tomorrow. If we are not here tomorrow, that does not mean anything, because all we would be doing tomorrow would be going over this review and starting our next unit, yes? If we are here tomorrow, this review will get marked. If we are not here tomorrow, this review will be posted as a video. Watch it. Because if we are here Wednesday, you're writing a test on measurement. Everybody understand? If we're here tomorrow, no big deal, no problem. If we're here tomorrow but not Wednesday, when are you writing your test? The next day we're back. Okay? Now, classes go, if I'm not mistaken, we've had this discussion, until the 23rd, if I'm not mistaken. That's the first day of double blocks. 1, 2, 3, 4, 5, 6, 7 classes left. Right? Trigonometry is, to do it, to learn how to do it, takes 2 days. It actually only takes 1 day, because there's only one thing you have to learn: how to do. There's a little bit of theory, but other than that, trig has one and only one concept: And if you can do it and you practice it, it's easy. Because there's only one thing you can do. You're going to get two numbers, and you got to multiply or divide them every single time. All right? That is why I have no problems with where we are right now. Okay? All right. Everybody understands? Okay, let's look at these couple of questions. Again, we're just going to talk about the first one. I lie. We're going to do the first one. You're going to do the second one. The third one. Then I'm going to talk about the fourth one. And then you're going to be totally on your own. Okay? So let's talk about that first one. When I say we are solving formulas, that means we are going to isolate a variable in the formula. That's what it means. To solve any algebra question, anything with variables, solving means you isolate the variable. There's two ways to do it. First, we're going to write it out. What formula are we using here? We need the surface area of a cone, right? So SA equals, if you don't have it memorized, you would look on that sheet I gave you. That sheet I gave you tells you that the surface area of a cone is pi r squared plus pi r slant. Yes? Now, there are two ways you can do this. One is called manipulate the equation. Now, ladies and gentlemen, I'm not going to lie to you. This is what your future teachers want you to be able to do. They want you to be able to do what I'm about to do in red. Okay? Over here, you can solve the equation. This is what you could do in real life. All right? Look carefully at the differences. If I am moving around the equation, that means I am not putting any numbers into it. I am only using this. All right? Now the question says I need the slant height, right? Everyone agrees? So that means what letter here has to be by itself? S. So we would move everything around until S is by itself. SA equals pi r squared plus pi r slant. Everyone agrees? Okay. If I gave you this, 3r plus 7 equaled 9, what would you do first? You'd subtract 7, yes? Because 7's just a number, isn't it? Okay. Do you see anything here? I'll change it. How many terms do you see here? You have to think back to the third unit on polynomials. How many terms do you see there? 3. There is term 1, there is term 2, there is term 3. Yes? Because these are all multiplied together. Then we have a plus. Then they're all multiplied together. So we got 3 terms, yes? How many terms do I have over here? 1, 2, 3, right? And you all told me you would get rid of this term first. Why? Because there's no variable in that term. Absolutely, right, Gerzil? Where here has the variable that we are trying to find? Term 3, yes? So I can't touch term 3 until when? Till everything else is dealt with, yes? Just like we wouldn't touch this term until we dealt with the 7, yeah? Okay, how do I get rid of the 7? I subtract 7, yes? What if I told you 7 was 2 times m. M would be 3.5, right? Because that's half of 7. Yeah? So what would you do if I told you this was 3r minus 2m equaled 9? You know that's 7. Oh, it was plus, wasn't it? You know that's 7. So you would do take away 7, right? But now it's written as 2m. So you would do take away 2m, wouldn't you? So how do I get rid of this? I take that away, yes? So I would have surface area minus pi r squared equaled pi rs, right? Everyone agrees? So over here, I would have had 3r equal 2, yeah? Because I took away 7. Or I have 3r equals 9 minus 2m. Now what would you do with that 3r? You divide, right? What would you do with this 3r? You divide. So you would divide that by 3, wouldn't you? So what do we got to do here? I've got pi times r times s. So what do I got to do to get rid of times times? Divide. So the surface area minus pi r squared divided by pi r equals s. That is what your Physics 11 teacher wants you to be able to do. He or she and future math people will want you to be able to do math with no numbers. Now please notice how easy it is. It's exactly what you've always done, but you have to leave all those variables in there. Cool? And then, of course, we would substitute what we know here. Do we know the surface area? What is it? 1,200. Do we know the R? What is it? 5. So we would just solve it. Everybody cool? This, for some reason, this red work is very confusing to you people. No, it is. I've been doing this 22 years now. This, I could never do that, Mr. Myers. That makes no sense. But over here, all of you could do it in your sleep, right? I don't know why the red is difficult. But kids often can't do the red. Now look what happens if we change it and put in the numbers right away. What number goes in for surface area? 1,200 equals pi. What's r? 5 squared plus pi times 5 times s. Agreed? Okay, what's 5 squared? 25 pi plus 5 pi s. Agreed? Well, isn't 25 pi just a positive number? Like 7? So we do minus 25 pi. 1,200 minus 25 pi over, now this is gone. Now I've got 5 times pi times s. So what do I got to do to get rid of the 5 and the pi? Kids like the blue better. I don't know why. But do I care why? As long as you can do one of them. And really, what's the skill here? It's just algebra. Everybody good? That's the work. You're going to find me that answer. You're going to do number 2. You're going to do number 3. All right? Now, number 3 is a little weird. Some of you won't be able to do that on your calculator because you don't know how to find a cubed root on your calculator. If you get to that point, just leave it. Understand? Now, I told you I wanted to show you 4 because number 4 is a little bit weird. Actually, you know what? Skip it. Why do we have to skip 4? No, because you could do this. You could do 1.5h plus 7 equals something, right? If I told you I want a by itself, right? So that's pretty easy, isn't it? How would I get rid of this negative 4.9t? I'd add it. So I would have h plus 4.9t squared. How would I get rid of this 12? Minus 12t equaled a, right? Given a height of 100, where does that 100 go? So 100h, right? Plus 4.9 t squared minus 12t equals a. Can we isolate t? No, because there's 2 variables there, right? You cannot tell me what t is. In grade 11, you'll learn how to deal with that. Believe me, you actually know how to do that right now, but because the number is yucky, you can't. But you actually know what to do with that. But you'll see it again in grade 11. Everybody cool? Okay, you got these questions to do and get started on that review. Now, when you do that review, you will notice I have started with conversions here. You have to think, because not every one of these conversions is on your conversion sheet, right? If I wanted, for example, inches to millimeters, is that on your conversion sheet? No. What is? Inches to centimeters. So then you would need to go inches to centimeters, then centimeters to millimeters. Everybody understand? Because, of course, in metric, it's all the same thing, isn't it? Millicenti up to kilometer, it's just moving the decimal. So you find the one you can do, and then you move the decimal to get you where you actually need to get. Everybody understand? Yeah? Okay. Go. Number 31 is not a real question. It's a bonus question like it says. And then everything else is okay. Are these still in yours? The photocopying is a little bad. So there's a range of answers I will take. All right? Just do the best you can because the photocopying is a little poopy. Right? Go. And once again, we will be testing on Wednesday. If we're not here tomorrow, watch this as a key tonight or tomorrow night. Okay? If I am not here, we are not here to mark this, then this will not count for an assignment. Does everybody understand? Because if I put up the video and you copy it all down, you come and look, I got 100%. Horse crap. All right.